Last chapter we learned about how we can use the tangent ratio to find missing side lengths if we have a leg and we're looking for the other leg. This chapter we're going to introduce sine and cosine ratios, which kind of go along with the tangent ratios. So much like I told you guys with tangent ratio, before you start, the first thing you should do is you should label your diagram. We've got our reference angle, and this is going to become even more important to understand which one is the reference angle, because that is going to tell you which leg is opposite and which leg is the adjacent leg. So in this diagram, I like what they have, but they're missing the words leg. And I like to have the words leg there because if you look at this, that's the opposite leg. It's across from your reference angle. And then this one is the adjacent leg. And the word adjacent just means next to. But if you look at that diagram, there are two sides that are next to angle theta. One of them is the adjacent leg and the other one is the hypotenuse. So that's why I like to have the word leg there, because it's not just an adjacent side, it's an adjacent leg. So let's start with the sine ratio. Sine is spelled S-I-N-E, but when we abbreviate it, when we write it in our equations and everything, we just write the words S-I-N. That's the abbreviation. But you should still be saying it as sine. So sine of theta is going to equal the ratio of the opposite leg divided by the hypotenuse. So it's very similar to what we had for tangent, but tangent was the opposite leg divided by the adjacent leg. And then we have cosine. And cosine is abbreviated just COS. That's how you're going to see these in your calculator, is SIN and COS. So the cosine of the reference angle is going to be the adjacent leg divided by the hypotenuse. So now I have three trig ratios that I can choose from when I'm trying to solve a right triangle. So let's take a look at this first example. Remember, anytime you're coming upon an example in your work, I want you to make sure that before you even pick up your calculator, the first thing you're going to do is you're going to identify what your reference angle is. So in this case, my reference angle is 17 degrees. And then I want you to label the opposite leg. So here's my opposite leg, is across from 17 degrees. And label the adjacent leg. The adjacent leg, in this case, it's already has the value of 3, and label your hypotenuse. And then I highly recommend that you guys get into the habit of highlighting the side lengths of your triangle that have either a value or a variable. So in this triangle, the hypotenuse has the variable x, and the adjacent leg has a value of 3. A lot of times you'll hear me say, what do you have? When I say what do you have, I'm talking about what is labeled with either a value or a variable. So looking at this now, I can see that I have the adjacent leg and the hypotenuse, so that means that I'm going to want to use cosine. So before I get my calculator, I'm going to write my equation out. The cosine of my reference angle, which in this case is 17 degrees, is going to be equal to the adjacent leg, 3, divided by the hypotenuse, x. Okay, now at this point I need my calculator because I don't know what the cosine of 17 is, but my calculator can tell me what the cosine of 17 is. So I'm going to do the cosine of 17 degrees, make sure your calculator's in degrees and not radians, and I get that that is 0.956, and then it keeps going. Remember, I don't want you to round until you get to the very end. X is in my denominator, so that means I have to do a little bit of solving, so I can multiply both sides by x to get it out of the denominator, and then I'm going to do dividing both sides by the whatever I had as the cosine of 17, which is 0.956. And when I do that, I'm really going to be doing 3 divided by the cosine of 17. Use your calculator to pull that answer down. Don't type it in, because then you'll get some rounding errors. And when I do that, I get that x is equal to 3.137 and so on, and I'm just going to round it to 3.14. So that is how I use the cosine. Okay, here's another example for us. I'm going to start by marking my diagram. So here is my reference angle. It's in a different location this time, but that's okay. That's why I label everything, is so that I can keep straight what I have and what I don't. This is the opposite leg. It is across from my reference angle. That would make this one the adjacent leg, and that makes this one the hypotenuse. I'm going to get my highlighter again, and I'm going to highlight what I have, what is marked with either a value or a variable. I have a hypotenuse and the opposite leg. That tells me that I'm going to be using the sine ratio this time. So I'm going to write out my ratio. I'm going to have the sine of 25 degrees equals my opposite leg, which is x, divided by my hypotenuse, which is 9. Now I can go to my calculator and type in the sine of 25, and I get 0.4226 and so on. I'm going to leave it in there like that. To solve this equation, I need to multiply both sides by 9. That'll get x by itself. So I'm just going to do times 9 in my calculator. And that gives me that x is equal to 3.80. All right, one more example for your right side notes here. Again, I'm going to start by labeling what I have in my diagram. Here's my reference angle. This is the opposite leg. That makes this one the adjacent leg. And this is the hypotenuse. I get my highlighter and I highlight what I have labeled with a value or a variable. And this time I have the opposite leg and the adjacent leg. That means that I'm going to want to do the tangent ratio. So I'm going to do the tangent of 62 degrees equals my opposite leg, which is 5, divided by my adjacent leg, which is x. Go to my calculator to do tangent of 62, and then I'm going to have to do 5 divided by that value because x is in the denominator, and I get x is equal to 2.66. And now you have 3 really nice examples of the 3 different trig ratios.